Hi, I'm Ying Fan. Now, I'm going to present my final year academic project with the title Autonomic Control for Laboratory Experiment using Single Board Computer and Microcontroller. Autonomic Process Control is a computer-based process control system that is used to address control systems which cannot be achieved purely by human manual control, and to achieve a desired production, economy, and safety. Feedback control is a common process control strategy used, where a typical feedback loop consists of a controller, process variable to be controlled, sensor, and set point. The selection of controller should be done properly because it is very important to ensure the excellent performance of the plant by maintaining the stability and robustness of the control system. Proportional integral derivative PID controller is a conventional and widely used controller in industry because it is very easy to be implemented. However, it exhibits poor performance when applied to non-linear systems because controller tuning is difficult due to insufficient knowledge of the parameters of the system. PID controller corrects the errors based on proportional, integral, and derivative term PID. Fuzzy logic controller. Fuzzy logic control idea was originated by Lochtizadeh, 1973, to deal with control system which is difficult to model. Fuzzy logic provide a means of expressing value in degree from 0 to 1 rather than 0 or 1. Fuzzy logic control provides a method of converting a linguistic control strategy based on expert knowledge into an automation control system. This is the block diagram of a fuzzy system. First, the crisp inputs, for example, the exact inputs measured by sensor and passed into the control system for processing. Examples of crisp inputs are temperature, pressure, or many others. And then the crisp input go through fuzzification to convert into fuzzy input. Fuzzy rule base are set according to expert experience and work together with fuzzy inference system FIS to give fuzzy output according to fuzzy input that received. And then fuzzy output will have to go through the fuzzification process to give crisp output to controller to the actuator as a controller output. Arduino Uno is a microcontroller board based on the ATmega 328P. ATmega 328P is a single chip microcontroller. Arduino Uno has 14 digital input and output pins, which are used to acquire data from sensor to controller and channel the controller output to actuator. It also has USB connection and it is programmable. Arduino Uno is programmable using computer by making connection to Arduino Uno through USB. The problem statement of this study is PID controller is widely used in industries because it is flexible and easy to be used. Many industrial processors characterized by highly nonlinear dynamic and parameter uncertainties do not give satisfactory responses using conventional controllers. Fuzzy logic controller is believed to have better performance in controlling nonlinear systems compared to PID controller. Fuzzy logic is used mostly to handle high-level control functions that traditional control methods do not address. Therefore, the performance of PID and fuzzy logic controller should be compared. The main objective of the study is to compare the performance of non-conventional PID controller and fuzzy logic controller for process control experiments using single board computer and microcontroller. The specific objectives are to develop the theoretical models for process control equipment and analyze the dynamic behaviors with the help of MATLAB Simulink. Also, it is to establish the connection between the process control equipment with the single board computer and microcontroller for both conventional PID controller and fuzzy logic controller. Thirdly, it is to evaluate the control performance such as response time, set point overshoot, and steady-state error for both controllers. The major scope of this study is to evaluate and compare the performance of conventional PID controller and fuzzy logic controller for a process control experiment. Offline and online process control will be carried out to observe and evaluate the performance. Aspects that will be investigated are response time, set point overshoot, steady-state error, and transient behavior. However, this study is limited by the choice of control experiment. This is because only level control and dissolved oxygen control laboratory equipment are presented in Department of Chemical and Environment (UPM). Then I'm going to talk about literature review of my study. In 2014, Hu and his colleagues, in his review paper, PID Controllers Design and Tuning Methods, they concluded that PID design procedure should include process model identification, controller structure design, and PID parameters tuning. This paper is important for me to find out the methodology on how to develop a PID controller for the study. Then, in 2012, S. Krivik and his colleague, in his paper, Design and Implementation of Fuzzy Controller on Embedded Computer for Water Level Control, the performance of PID controller, one input fuzzy controller with error as input, and two inputs fuzzy controller with error and current water high as inputs were compared. And then they find out that fuzzy controller was better than PID, but two input fuzzy controller did not provide significant improvement compared to one input. And then in 2014, Munadi and Akbar, in their paper Simulation of Fuzzy Logic Control for DC Servo Motor using Arduino based on MATLAB Simulink. Their PID controller was designed using MATLAB's Single Input Single Output design tool, and the Fuzzy Logic controller was designed using MATLAB's Fuzzy Logic toolbox. They found out that Fuzzy Logic control had smaller overshoot and better stability. And then, Pamanathan and Ibrahim, 2010, in their paper Development and Implementation of Fuzzy Logic Controller for Flow Control Application, their Fuzzy Logic Controller was designed to have two inputs, error and the rate of change of flow, instead of rate of change of error, to reduce the extreme variation in manipulated variables. This is because the derivative move, or we call this the rate of change, amplifies the sudden changes in controller. It will cause large variation in controller input signal. And then they found out that Fuzzy Logic controller gave better settling time and 0% steady-state error, but 2.9% overshoot as compared to PID controller. And then Fuzzy Logic controller was more stable under bubble noise disturbance. Then, in 2016, Black and Azizi, In their paper, Comparison of Mandani type and Sugeno type fuzzy inference system for fuzzy real-time scheduling, they found out that both Mandani type FIS and Sugeno type FIS, we call it fuzzy inference systems. Both of these Mandani and Sugeno type, they perform similarly. And then Sugeno type FIS model allowed the system to work at full capacity. Then I'm going to talk about the methodology of my experiment. So firstly, the experiment should be started with empirical data collection using laboratory equipment. This can be done by introducing step response into the manipulated variable or the process input. For an example, in level control, introducing step function into changing the pump voltage, and then the data can be obtained and plot into graph for further analysis. Then we will go into theoretical process model development using first order plus dead time model. And then MATLAB simulation for both PID and FLC controller, while the PID controller was tuned using Ziegler-Nichols tuning method, and FLC is designed by using MATLAB toolbox, and we choose the Sugeno type FIS with the finely tuned parameters. And then we can go into online control by the establishment of connection between the process control equipment and Arduino Uno. At the end, data analysis for both simulation and real control, we call this online control system. We collect the data and the performance will be evaluated. This is the control online setup. The Arduino Uno is priorly programmed by using computer and put into real use. So it will have a data acquisition from process sensor, and the controller output will go into the process actuator. So in this case, level control process sensor is level sensor, DO is DO sensor, and process actuator is water pump for level control and air pump for dissolved oxygen control. So the expected outcome of the study is simulation of MATLAB is able to give properly tuned controller that will be used in online control. Also, we believe that fuzzy logic control have better performance than PID controller. This is the Gantt chart. I have planned from week 13 this semester until week 10 the next semester. So by the end of this semester, I expect myself that I will be able to come out with chapter 1, 2, 3 revision. While starting from next semester, I will start doing the empirical data acquisition and then model development, MATLAB coding, applying process control, and the connection between the Arduino Uno and to the process equipment, then online process control, data analysis, and performance evaluation, and at the end, the thesis production. So this is the reference list that I have included 8 journals in my in this presentation slides. And thank you for watching. Thank you for spending the time to review my FYP. See you. Bye bye.